Hey everybody, today we will do another problem, and it's going to be in the digital logic. So the problem says the following: write. If I have a marker that works, it'll be much better. Write a truth table that represent the following circuit and write a Boolean expression. Okay, so that's the problem statement, right? Now we gotta do we have an A, and from A I have a wire going to a NOT gate, right? And this NOT gate has a little bowl like that, and from that I got to an AND gate, right? So actually do this like this to have a little more room to the other one. Okay, and then I got a B, and from B I got a wire and go to another NOT gate and goes like that. Then I got right here another wire coming out, and I have an OR gate, right? Like that, which is like, it's not easy to draw those little things, but I mean, you get the idea. The OR gate has the little half moon, right? The AND gate is just a straight. The OR gate has a little half moon like that, right? So, right now, from that, I got a wire coming down, and it goes like this, and it goes to another AND gate, right? I need some room for this, so let me just do it like that, right? So now, notice that I got from here, I got another wire coming in, and it's going straight to this AND gate, right? And then from this AND gate, it goes like this, and it goes like this, and this has an output of X, and here, right? However, this should have names too, right? Because technically, after the value of A is being modified by this, and the value of B coming in from this one I have no problem, right? It's coming straight from A to this AND gate, and from B to this AND gate. But over here is being modified. So I want to call that C, right? C. And then call that D. And then call this E, right? E, and call this F, right? Now we're talking, right? We have labeled all the points where this has a change, right? And so now that we have this, right? So we have A going through here, going straight. If A goes straight, right? And think about electronics, right? Think about when you have a button and you say no to something, right? And think about the computer, right? You write an email, but you don't send it. You just that email just sitting there. You might get a message that you got a draft. I don't think it doesn't mean anything to the end user of that email. It means something to you because you wrote it and the messages say that you have a draft, but you didn't send it, but it doesn't have an effect in others, right? So the same thing. So this is negating what is coming out of here. If this was a button, right? If this is in the off position and I turn it on, then allow electricity or the signal, in the case of the email, to go through the AND gate and do something in the AND gate and coming out over here. Okay. So now the same thing over here, right? If this is the condition of this is not, and I want to say yes. If I want to say yes, I have to override whatever value this is over here. So what I mean by override is override whatever value it is, right? So if it was no, I say yes. If it's yes, I say no, right? So that way, right? So the same. It is. That's why I have a reason to call this is called a logic gate, right? So let's try to do a truth table, right? So we know they're going to have a truth table that is going to have A, it's going to have B, right? And we know there's going to have C and D, right? But for now, we will just focus just filling up this, and we write, start with 0, 0, right? A being 0, B being 0. The car is on. The car is off, right? Nothing. You didn't turn out the key. Nothing even the initial key. It's just off. Everything is equal to 0 at this point. 0 and 0, right? Once you turn the key on, and then you see the dashboard that turns on, then something is going on, right? One of them has to be on, right? So then we said, okay. So we said 0, 1, right? And then of course the next state is going to be swap them. It's going to be 0, 0, 0, 1, right? 0, 1, 1, 0, 1, 1. Right. So 0, 0, 0, 1, right? 0, 0, 0, 1, 1, 0, 1, 1. You try to give the value to all of them to correspond to each other. Try not to discriminate, right? See how I swap them over here? Give them an equal value, right? And of course, in this case, it's just, they both say yes, A and B is saying just in this case, right? You wrote the email, you send it. Okay. And the computer understand that you send it, you say 1. When you say you send it, wherever. Okay. Anyway. So now let's do so now let's focus in the other part of the table. Right? So now this is this part, right? Now let's do lowercase z and lowercase d. Right? So C and D. Lowercase c, lowercase d. Notice that I am trying to negate. I am trying to say no if it's yes, and I'm trying to say yes if it's no. I have a no, no. I say yes, yes. 1, 1. I say that 0 is equal to no, 1 is equal to yes. So 0 is equal to no, 1 is equal to yes. I say yes is equal to 1 over here. And this yes over here is equal to no over here. So I put a 0 in there. Or you can say true and false too. There's another way to say true and false. This is true. This is false. If it's true over here, I gotta take false over here. If it's false over here, I gotta take truth over here, right? So I said this is false, which is technically this is false. This is 0, right? Then this is 0. This is false. This is 1, right? 1 is equal to true. And then this is, of course, this both are true, which is 1, 1. Another way, this is like this, right? If you want to do this table like this, also valid. You say true, 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 false, false, true, true, true. Right? Maybe that makes more sense. But that's how the logic works, right? Now, let's do this again. Okay, so not do it again, but just do the rest, right? So now, think about this, right? So now I already negated, right? But I still need 2 more columns. I got an E and F, right? I got an E, and F. Okay, so this one, in order for me to get, in this case, right? So let me make a little more space over here because I think I need a little more space right here. So let me just F right there. Okay, so what is the result, right? if A is, if C is true and D is true, then E coming out of here, right, is true, right? So then, if that is true, then because, okay, so let's say A and B, if A is equal to 1, B is equal to 1, this is equal to true. But if A is not A and B is B, then it's equal to false, right? Okay, so if that is the case, I got I got a C coming in, and that C over here is what? The first one, C, is true, so this is 1. 1 and 1, right? And the rest, this is 1 n with 0 is 0. 0 n with 1 is 0. 1 n with 1 is 1. Okay, so now that we have that, right? What do we have for F? For F, what do we have for F, right? And remember, still when I have a column, this is the last column, this is going to be the output, right? But at the moment, I am concentrating in this, right? A and with B, remember, this guy is being A and B are being N, but they are straightforward. So in this case, right, A and B, this is 0. A and B is also 0 because 0 n with 1, 0. A is 1, B is 0, this is 0. 1, n with 1, this is 1. Okay, now, so look over here. So this is not, okay, so this is not C, N, not D. This is A, N, B. It's A and B coming over here. So then this coming out over here, this is equal to F, right? So in other words, F is equal to A and B, and E is equal to not C and not D. Now, these two are coming out of these two AND gates. They coming out of here and they united together over here. So this is coming together at this point. So with that being said, now we have the following. So we have an AND gate. So the value coming in over here, remember that the AND gate is going to depend on E and F, right? I'm sorry. This OR gate, the OR gate is going to depend on E and F. Now, look at this. 1 or 1 is 1 or 0 is 1. 0 or 0 is 0. 0 or 0 is 0. And 1 or 1 is 1. Okay. Now, the last step is to write. So we have now the truth table. Now we need to combine this together and put it into an expression, Boolean a Boolean, expression. Okay, so the Boolean expression is the following. It's going to be x is equal to something, right? X is equal to A and B, right? Okay, A and B, right? Because it's coming over here, A and B. O is going to come over here and it's going to say, but remember something here, right? Let me just write this. This is being negated. So these things are, we using these variables over here just to represent these nodes. But this A and B is being negated at this point. Not A, not B, because it's negated over here. This is a regular A coming in, but then something say no to it. When that no comes in, it's negate whatever value. The previous value of A was override, but this, whatever it was true, becomes a false. If it's false, it becomes a true. Okay. So now the expression over here is going to be, not A, not B, or not O, A, and B. Right. So the final expression is going to be not A, N, not B, O, not OA, right? Or regular A and B, right? In other words, it's like this, right? So X is equal to A, not A, and B, right? Not A, not B, O, A, and B. So that is the truth tables. So the answer is for this is the Boolean, right? This is the Boolean expression. And this is the truth table. Right? So, okay, so that is basically this problem. It doesn't require a lot, but it's still, it's a good way to think about this, because you got two gates over here, right? Those gates are being negated by these two not gates, right? Okay, I'm sorry. These two variables are coming over here, right? And they are being negated by these two not gates. And then over here we have a regular, right, AND gate. And when those come together over here and to an OR gate, right, and then you express it, when you do the truth table, you find out that the only value that you have on OR has a value of 1 is when either of the two are 1, or when both are 1, the value of X over here is 1. Okay, so that's for today. Thank you for watching, and until the next video.